Welcome back, everyone. Thanks for joining us. I'm Steve,
And I'm Scott.
and together we're Backyard Musings, Apple Valley, and Utah.
Yep. And we are the Science and Technology Channel, experts of
Yep.
nothing.
The experts of nothing. That's what my wife says. So, really interesting. Well, I say that all the time, but this is really interesting. You remember in Star Wars when Dooku escapes, he cuts off, Anakin's arm, and he escapes, and his ship goes into orbit, and these sails come out, and then he travels back to Coruscant, right?
Four,
Fast.
5, and 6.
Yeah,
Any
I
other
don't, I
any
don't
other
know.
any other Star Wars
What does it matter,
episodes?
Scott? You haven't watched it. Does it matter? You haven't watched it.
4, 5. I have watched it. 4, 5, and 6. I've watched all of them.
Oh,
4, 5, and 6 are the only Star Wars that are worth talking about. Anyway, on to the subject.
no, I think this was number 2 because Anakin was grown up. So I
Yeah.
think this was 2. All right.
Yeah.
A new collaboration between Brown University and TU Delft has brought us closer to interstellar travel using light-powered sails. By combining ultra-thin, highly reflective materials with AI-optimized nanoscale design, researchers created a revolutionary light sail that's cheaper, faster to make, and possibly scalable to missions like Starshot, aiming to reach nearby stars in just decades rather than millennia. The research was funded by the European Union, ERC, EARS, and a Limitless Space Institute Grant. Would you like to know more?
Since it launched in 1977, NASA's Voyager 1, I remember that, Voyager 1 spacecraft has traveled more than 15 billion miles into space. And it's amazing that thing is still out there.
Yeah.
That's an incredible distance. Yes, it's still less than 1% of the way to Alpha Centauri, the closest star to our sun.
That's 50 years now. 50 years, less than 1% of the distance.
Yeah, amazing.
Yeah.
To reach other stars within a human lifetime, spacecraft will need to travel much faster than anything we've built so far. One promising solution is a light sail, a thin, reflective sheet that uses the pressure of light to propel itself, similar to how wind pushes a sailboat. Compared to conventional propulsion systems, light sails could dramatically reduce travel time to nearby stars, potentially cutting it from thousands of years down to just a few decades.
So, Scott, you're telling me that light pushes a sail. Light.
Yeah, I don't know. I mean, if somebody told me that I knew was a pretty smart person, I'd probably believe him, I guess. But I don't know.
I don't know. This sounds like a conspiracy theory, man. It sounds kooky.
Well, I don't know. I mean, could you
Okay.
imagine? This is getting to the point where we're approaching beam status, right? Like, beam me up, Scotty. I mean, they're going to be traveling through.
Well, we already have that with facsimiles, fax machines. That's beaming.
Well, yeah, but you're not beaming a body, right?
Right. Still, it's same principle, just paper and digits instead of human bodies.
Yeah, it transfers data from one, takes a picture of it, transports it through the wires or whatever, the waves, and then replants it on a piece of paper. So
yeah.
All right.
So now researchers from Brown University and Delft University of Technology in the Netherlands have developed a new method for designing and building ultra-thin, highly reflective light sail membranes. In a study published in Nature Communications, the team describes a prototype that measures 60 millimeters, that's about 2.5 inches, across, but is only 200 nanometers thick. I mean, that is really thin or thick. Thousands of times thinner than a human hair. Its surface is covered with billions of tiny holes at the nanoscale, which reduce weight and boost reflectivity, making it more efficient for light-driven acceleration.
Quote, this work was a joint effort between theorists at Brown University and experimentalists at TU Delft, making it possible to design, fabricate, and test a highly reflective light sail with the largest aspect ratio recorded to date, said Miguel Bessa, an associate professor in Brown School of Engineering who co-led the research with Richard Norte, an associate professor at TU Delft. That's cool that they were collaborating. Quote, the experimental breakthrough of Richard's team proves their fabrication process is scalable to the dimensions needed for interstellar travel and can be done in a cost-effective manner. Simultaneously, my team is very enthusiastic to see the essential role of our latest optimization method guided by machine learning in solving such an interesting and difficult engineering problem, unquote.
The research is a significant step toward realizing goals like those of the Starshot Breakthrough Initiative founded by entrepreneur Yuri Milner and the late physicist Stephen Hawking. The goal is to use ground-based lasers to power hundreds of meter-scale light sails carrying microchip-sized spacecraft. Okay, hold on. Microchip-sized spacecraft.
Do you remember that movie? I think we talked about it before. What the heck was it called? They shrunk these guys down and they put them in a capsule and they embedded them in a body.
Yeah, I remember that.
That was back in like the 60s, I think. I
forget
the name of that movie.
So we're going to shrink people down and put them on this microchip.
I don't know. Is anything impossible?
I don't know. Do I keep going? Was this you or me?
How about you?
Okay. This new light sail design could be scaled up to meter scale fairly easily, the researchers say, and with a manageable price tag. So if you got it up to a meter scale, you could put one person on board. Okay.
Oh, I think that was me. Okay. For their design, is that where I'm at? For their design?
Yeah.
For their design, the team used single-layer silicon nitride, a lightweight and high-strength material that's well-suited for light sail design. The researchers then worked to maximize its reflectivity while maximizing its weight. The reflectivity of the surface determines how much light pressure is created behind the sail, which in turn develops how fast it can accelerate. At the same time, a lighter material requires less force to accelerate, so less mass equals more speed.
Yeah.
So the smaller and lighter, the faster you're going to go.
Yeah, I reckon so. So that's why they got to shrink you down to microscopic. Okay. And then that microscopic chip, that could be like a Borg cube, the equivalent of a Borg cube with hundreds of people in it. Wow. Okay. The optimization process involved designing a pattern of nanoscale holes, billions of them across the material's surface with diameters smaller than the wavelength of the light. Bessa's team, including Brown PhD student Shunyu Yin, used a new artificial intelligence method they developed to optimize the shape and placement of the holes for increased reflectivity and decreased weight.
Once they had an optimized design, a team led by Norte at the TU Delft went to work fabricating again in the lab. Quote, we have developed a new gas-based etch that allows us to delicately remove the material under the sails, leaving only the sail, Norte said. If the sail breaks, it's most likely during manufacturing. Once the sails are suspended, they are actually quite robust. These techniques have been uniquely developed at TU Delft.
Cool.
Yeah.
Fabricating this design with traditional methods would have been expensive and taken as long as 15 years, the researchers say, but using Norte's techniques, fabrication took about a day and is thousands of times less expensive. The result is a membrane that the researchers believe has the highest aspect ratio, centimeter scale length, but with nanoscale thickness of any light sail design to date. The researchers hope that their methods will not only help humans reach the stars, but also push the limits of nanoscale engineering.
Quote, the new machine learning and optimization techniques we used here are very general, Bessa said. We could use them to create lots of different things for different purposes. This is really just the beginning. we might be on the verge of solving engineering problems that have remained unsolvable up to now. Unquote. Fascinating.
Yeah. So Scott and I talked about reducing people to microscopic size. That was kind of tongue in cheek. I don't think that happens now.
There was a movie, though.
There was a movie, but I don't want you to think that we're conspiracy theory kooks. The article was about nanoscale size light sails, and we were being kind of a little bit funny, microchips guys, So don't take us literal. This is fascinating, the whole
Ever.
light sail thing.
Ever.
Scott's got the dry kind of humor that you'll be like, oh, okay.
Take
All right,
care,
folks.
everyone. Thanks for listening.
Catch you on the next one.